Hello, in this class we are going to prove that in an integral domain R with prime characteristic p, x plus y raised to p is actually equal to x raised to p plus y raised to p for any two elements xy of the ring R. So here we are supposed to note few things. The first one is R is an integral domain, therefore the ring is commutative and the binomial theorem can be used. Second, the characteristic of the ring is P. It means Px will be equal to 0 for all x belongs to R. And the third thing is P is a prime number. Now let us begin with the proof. So I will say let xy belongs to R be any elements, and let us consider x plus y raised to p. So by binomial theorem, it is actually equal to summation R is varying from 0 to p combination R, x raised to p minus r, y raised to r, which is equal to, so first of all I will put the value of r as 0. So this will be x raised to p plus summation r is running from 1 to, I will also put the value of r as p. So what you will get, y raised to p, isn't it? And now this summation will run up to p minus 1, and this will be p combination r, x raised to p minus r, y raised to r. Now if we are able to show that these terms are actually equal to 0, there are p minus 1 terms here, right? So if we are able to show that these terms are 0, then we are through, isn't it? Because we have x raised to p here and y raised to p. So that is exactly what we want to prove. Now in order to prove this to be 0, naturally we have to make the use of two facts now. The first one is the characteristic of the ring is p and p is a prime number. So let us try to elaborate it. Note, what is the formula of p combination r? P factorial upon p minus r factorial into r factorial, where this value of r varies from 1 to p minus 1, isn't it? Now we already know that the numerator p factorial can be written as p into p minus 1 factorial upon p minus r factorial into r factorial. Now see what is the trick here. If we are able to prove that this p combination r is divisible by p, then we are through. Why? Because you can see that this is actually a element of a ring, and if p divides this quantity, then I can write it as p and some quantity here, and it will be multiplied by a element of a ring, right? This as it is in fact. So p multiplied by a element of a ring will be actually equal to 0, because characteristic of a ring is p, right? So now the only thing that is left out to show is that this is divisible by p. Now we already shown that the numerator is a multiple of p, means p is present in the numerator. If we are anyhow able to show that the denominator is not divisible by p, then we are through, right? Then there is no chance that this p will get cancelled out with the p in the denominator. Let us try to understand it through an example, then the idea will be clear. So choose any prime p, for example let us say 5, and thus what will be the possible values of r? So possible values of r will lie between 1 to 4, right? So what will be our denominator? It will be like 4 factorial, 3 factorial, 2 factorial and 1 factorial. I mean, these are the possibilities of r factorial. Now what about the possibilities of p minus r factorial? Remember, value of p is 5, so this is again taking the same values 1 factorial up to 4 factorial. So one can easily observe that none of these terms will be divisible by the prime number 5, isn't it? 4 factorial is 24, 3 factorial is 6, 2 factorial is 2, and so on. So thus, whatever may be the prime number p, this denominator will be never divisible by p. So we will write here, as p is prime and r varies from 1 to p minus 1, so the denominator p minus r factorial multiplied by r factorial will not be divisible by p, and therefore definitely p will divide p combination r, and therefore the summation r is running from 1 to p minus 1 p combination r x raised to p minus r y raised to r will be equal to 0 now, since characteristic of r is equal to p. So let us call it as sum 1 and let us call it as sum 2. So using 1 and 2, using 2 in 1 in fact, what we will get, x plus y raised to p is actually equal to x raised to p plus y raised to p for all x y belongs to R, and that is exactly what we wanted to prove.